Hello, everybody. I'm Dr. Huang from the Department of Biology at Jackson State University. The project I'm going to talk about is conserve water in CVD-PROTEIN'S active site for drug design, CVD for cardiovascular disease. Let's have a brief summary for the project first. Water plays an important role in the normal functioning of protein, and the conserved and stable water in the active site of CVD-related protein can be incorporated into the construction of the pharmacophore model for drug design purpose in order to cure CVD. As you can see from this example here, the HIV protease is a dimer with a pair aspartic acid residue in the bottom of the active site. And you can see a conserved water just positioned between a weak inhibitor and the enzyme flap on the top. This conserved water has been incorporated into this inhibitor as shown on the right. So eventually this new inhibitor with oxygen that came from that water position, and this new inhibitor will be more powerful and potent than the original one. So we are going to use the molecular dynamic, to put the cardiovascular disease related protein inside this, inside this water box to do the MD simulation. Then we are going to study the water around the active site, as shown in this kind of like a study. So the water moving around a substrate or inhibitor, but most of water moving around, but some water like the one you can see on the top here is very stable. So we are going to use the cluster analysis to look at like for example 125 friend, okay, that's like extracted with constant interval from 2 nanosecond simulation. And once this 125 friends are superimposed, we study all the water in the active site area, then do the cluster analysis to identify several water clusters. And you can see some water very stable, like 1 or 2 water stay there most of the time, but some water like have a lot of water moving around. We need this kind of stable water for drug design. So we can integrate that water position into a dynamic pharmacophore model. Then this like a refined model with the integrated water position can be used for drug design. Thank you for your attention. Goodbye.